Hi students, today we're going to do 15.2. Energy conversion. Energy conversion is when energy can be converted from one form to another. So if you turn on a battery-powered radio, what's happening is the battery has chemical energy in it, and that's converted to electrical, which then is turned into mechanical, which is sound energy. Law of conservation of energy. Energy cannot be created or destroyed, but it can change forms. So when a ball stops rolling on its own, kinetic energy is converted to thermal energy from friction. So you don't lose the energy. The ball's not losing the energy. It's just being converted from kinetic to thermal. So kinetic energy of something that is moving also equals the PE of that same thing when it is not moving, and that's an important point to know. Most conversions of energy are from kinetic to potential or potential to kinetic. For example, if you're dropping a bouncy ball, before you drop the ball, it has the potential energy is at its max when you're holding it in your hand. During the drop, the potential energy converts to kinetic energy. Right before it hits the ground, when the height is at 0, the kinetic energy is at its max. When it hits the ground, the elastic potential energy it turns into elastic potential energy and thermal energy because of friction, and then on the way back up, kinetic energy converts into potential energy. The reason why it doesn't bounce back up as high as it was is because some of the energy was converted to thermal energy during that friction, and so not all of that elastic potential energy converts back to kinetic energy. So remember, Ke of something moving is equal to the Pe of something that is not moving. So we're going to do this problem. A 0.15 kilogram ball is thrown into the air and it rises to a height of 20 meters. How much kinetic energy did the ball initially have? So remember, the kinetic energy is going to equal the potential energy. So in this problem, you need to figure out which one can we solve for, the kinetic energy or the potential energy. So in this problem, we have the mass and we have a height. If we have a height, that means we can solve for potential energy. So we're going to solve using the potential energy equation. So our kinetic energy is going to equal our mgh. So our kinetic energy will equal our 0.15 kilograms times our 9.8 meters per second squared times our 20 meters. If you multiply all of that, the Ke will equal 29.4 joules.